Questo è un luogo che genera dialogo,
Qualcuno che si impegna, che si batte.
che approfondisce la conoscenza e sostiene la fiducia. È un crocevia dove si incontra chi desidera il vero, il bello, il giusto e il bene. È una testimonianza di speranza nel cuore ferito del presente. E tutto questo
Proporre con la propria vita
esiste anche grazie a te.
Ciao, buonasera a tutti. Sono Brandon.
Good evening, everyone. I'm Brandon Vaidyanathan, professor of sociology at the Catholic University of America, and I'm honored to be here with you as a moderator. And it has always been my dream to speak in Italian and to deliver an entire speech in Italian, but this is not the day when I'm going to do it, unfortunately. I'm really sorry about that, because I'm going to say things that won't be correct, and then, well, it's better to switch to English. Really sorry.
I want to start. I want to start with a little story. A few years ago, I met a biologist at India's leading scientific institute. And she showed me this remarkable image. The images on the left of this slide are injection system needles of bacteria. They are complex machines that inject proteins and other molecules into target cells, including human cells. And she said, if I didn't tell you that this was a bacterial needle, you might have mistaken this for one of those stambhas or pillars of a Hindu temple, like in the nearby ruins of a famous temple near where she worked. And you can see the pillars on the right. She went on to describe the needle as not just a marvelous feat of engineering that would be very difficult for us to manufacture, but as beautiful works of art. If I were a painter, she said, I could have drawn it. It is this beautiful. This biologist was deeply moved by what she discovered. It wasn't an act of knowledge as conquest, but an encounter that led her to connect deeply with reality. I met this biologist as part of a study that I was conducting on the role of beauty in science. I spoke about it here a couple of years ago. We surveyed thousands of scientists in Italy, India, the United Kingdom, and the US. And we found that more than 80% of these scientists expressed, like the biologist I quoted, a profound sense of reverence for the phenomena they were studying and discovering. They felt that every new discovery opened them up to new mysteries. And this was true even if most of these scientists claimed that they were not religious in the sense of belonging to a religion. And so for the past 2 years, I've been trying to study what gives rise to this sense of meaning and mystery in reality. Max Weber, one of the founding fathers of sociology, saw science as a source of disenchantment. It strips away the magic and meaning and mystery from reality, he said. And that's the way a lot of people, even today, see it. But the scientists we studied insisted that science is in fact a source of enchantment. And this has to do not just with the profound beauty of nature, but the practice of science itself, which they felt constantly opened them up to new mysteries. Science regularly confronts us with new questions and puts us in front of the ultimate mystery. And then what do we do with that? I want to thank the organizers of the Rimini meeting for inviting this session, the John Templeton Foundation for sponsoring this study, and the panelists today who will discuss key questions raised by our research. Can science awaken the desire for something greater, something beyond what science itself can measure or explain? In a world increasingly marked by fragmentation and the loss of ultimate meaning, can scientific inquiry be a tool for reopening profound questions about the meaning of reality and of our presence within it? In other words, how can science help us live reality more intensely? Our panelists today are distinguished international scientists who will share their human and scientific experience, engaging with questions that inevitably arise when we find ourselves face to face with a universe that never ceases to spark wonder and awe. Let me introduce the speakers very briefly, and you can read their full bios at the meeting website. First, Dr. Dan Maoz is full professor at the School of Physics and Astronomy at Tel Aviv University, where he holds the George S. Wise Chair in Physics and Astronomy. He's known for his fundamental contributions to observational astrophysics, particularly in the study of supernovae, black holes, and planetary formation. Dr. Robert Gilbert is professor of biophysics at the Nuffield Department of Medicine at the University of Oxford. His research focuses on the molecular mechanisms underlying human diseases, particularly cancer, malaria, and inflammatory processes, and he is also an Anglican priest. Dr. Jennifer Wiseman is Senior Project Scientist for the Hubble Space Telescope at NASA's Goddard Space Flight Center. She is recognized for her studies on stellar formation and her involvement in the dialogue between science and faith. She also directed the Dialogue on Science, Ethics, and Religion program at the American Association for the Advancement of Science for more than a decade. And Dr. José Ignacio Latorre is director for the Center of Quantum Technologies at the National University of Singapore and the chief researcher of the Quantum Research Center at the Technology Innovation Institute in Abu Dhabi. He's also director of the Centro de Ciencias de Benasque Pedro Pascual, an institution that supports international scientific events, and he also leads the Quantic Group at the Barcelona Supercomputing Center and is the head of the Quantic Project, aimed at building the first quantum processor in Spain. So to start, I'd like to invite each of the panelists to share one example from your own scientific research that was deeply meaningful to you on a personal level, and why. What did this experience reveal to you about reality and your place in it? So Dan, let's start with you.
Grazie, Brandon. Buonasera.
Thank you, Brandon. I'm Dan Maoz. I'm an astronomist of the Tel Aviv University. My Italian friends call me Danny Maoz, and I like it. And I will now show you my slides. This is the rest of a stellar explosion, a supernova. And this is the rest of an explosion that was seen from the Earth the 1st of July in the year 1954. And it was registered by Chinese and Japanese astronomers who saw that a new star appeared in the sky on that day that was so bright that it was possible to see it during the day for a couple of months. And then it became feebler and feebler, but it was still possible to see it during the night for over 2 years. And then it disappeared. So they registered the exact point in the sky in the constellation of the Taurus where it appeared. So when we look at that point with our telescopes, this is an image from the Hubble telescope, we can still see the remains of this explosion. and all the parts of the star spreading in the space very quickly, very rapidly, about 3 million kilometers per hour. So these are the remains that you can see on the slide. These remains are made of gas, enriched with all the elements, all the chemical elements existing that are heavier than the two lighter elements, hydrogen and helium. When the universe was created 14 billion years ago, it was a very simple place made of hydrogen and helium. During its history, all the elements that we know, that surround us everywhere, and that are composing our bodies, all these elements were created solely through stars and through star explosions, like the one that I'm showing you in the year 1054. So these are actually the factories of nature that creates all the matter that we can see all around us. This topic is the focus of my research. It has been the focus of my research over the last years. And I'm trying to understand, to learn this history of the creation of all the elements during the history of the universe. There are so many things that I can't actually share with you now, but at the center of this image, you can see a very feeble star. It's a neutron star, so it is called today. It is a very dense matter. It's like a little spoon of this matter, weighs 1 billion tons, like a mountain. It's like a black hole, though not quite. This neutron star can actually produce light in all the different waves that exist in electromagnetic radiation, light that can be seen, but also X-rays. It's so very complicated, and it's part of this mechanism that turned the universe from a very simple place to the complex system that it is today, which is becoming always more and more complicated. Every day I feel the marvel of this complexity, and I wonder, what's going on? I don't understand. Non capisco proprio, in un termine più colorito, in a more English, very colorful term. So the marvel, the amazement that the universe arises has been an integral part of my scientific life. And I believe this is also a motivation for everything I do, because this marvel, all the questions that need to be answered are just a very small part of a bigger whole. And this makes me really happy. It's a source of joy for me every single day.
How about you?
Thanks, Brandon. So for my example, I'm showing an image here of a protein complex. The protein components consist of an N-modifying enzyme, which is colored as you see, and also a protein cofactor, which works with them. And they are bound to a microRNA. I'll explain in a moment what a microRNA is. This structural image was in fact generated using images of the kind that Brandon showed at the beginning of our session of the salmonella injection mechanism. You can turn these now into three-dimensional maps, and those three-dimensional maps can allow you to see the atomic structures of the complexes which are making up life processes. So we can see in 3D, but in fact in four-dimensional complexity, space and time, how it is that molecules go about their work and how it is that they modify processes in cells and how they determine health and disease. The microRNA, the pre-Let7 microRNA, which is labeled and shown in yellow on the slide, this is a very important microRNA. MicroRNAs, and we're all, I probably think, familiar with RNA molecules as used in the anti-COVID vaccines that many of us may have received. RNA molecules play critical signaling roles in cells, and in this case it's a very important tumor suppressor microRNA, so it acts as a kind of master switch controlling cell fate. And microRNAs of this kind are very topical because in 2024, the discoverers of these microRNAs, these Let7 microRNAs, received the Nobel Prize in medicine. Because of the structure that we have determined, which shows the enzyme, the N-modifying enzyme, bound to the microRNA, we understand in new ways fundamental aspects of how these microRNAs work. We can see how they are captured first by the microRNA. The microRNA, is captured by the enzyme, and then the enzyme engages with it and it modifies the microRNA, and in modifying the microRNA, it determines its fate. That's one thing we now know. Another thing we now know from a structure like this is the exact atomic chemical details of how that happens. And a close-in shot, which shows you a little bit of that detail, is showed on the right. So why is it so important for me as a scientist, and for scientists like me, to be able to image molecules in this way? Why does it mean so much to us? Well, for me personally, I've always found it delightful, really exciting to understand how it is that molecules engage with one another. A bit, you might say, like bricks of Lego. Building with new bricks is a key theme, the key theme of this meeting. And protein molecules interacting with one another and interacting with microRNAs are a bit like putting Lego bricks together in different combinations to produce different effects. And structures of this kind allow us to see in four-dimensional complexity how it is that those bricks are put together and how it is, therefore, that biology is changed. This has a kind of beauty to me, a fitting together, which is very delightful. And in fact, it's something which I have found fundamentally pleasing since I was a schoolboy. When I first started to understand how molecules come together to change how they work and how they're fundamentally structured. I found that delightful as a schoolboy, and I still find it delightful now, and that's why I continue to study molecules in this way. Another thing about this structure is it shows the critical role of this cofactor protein. It actually reveals things that no one knew about this protein. It shows that this cofactor protein plays a critical role, and how it plays a critical role in determining the fate of the microRNA. And in fact, something I didn't tell you is that this microRNA, this fundamental tumor suppressor, it can be matured by this enzyme to become active and suppress tumors, but it can also be caused to be degraded by this enzyme, and the cofactor center is the critical thing. So we see how all these things come together, and seeing how all these things come together helps us understand fundamentally how the system works. For me, that is very pleasing, and it's important because no one knew how this worked. It's also important because it's the culmination of 16 years' work. For a long time, we couldn't get anywhere with this system. All we had were fuzzy images, such as the ones actually that Brandon showed at the beginning, which we couldn't make atomic detail sense of. And then we were able to get atomic detail sense by an advanced electron microscopy technology, which actually also won the Nobel Prize in 2017, and also by the extremely dedicated hard work of a very gifted PhD student. And often in science, it's that fundamental contribution from the individual who goes in and makes all the extra effort that needs to be made that makes all the difference in showing that we can find something else. That previously, as Dan said, sometimes you look at things and you think, what the hell is going on? Well, often we look at things like that. And it's that dedication from someone that allows you to unpick things and really work out how things work. To turn to the second part, what does this say about reality and my place in it, or our place in it? Just a few things I want to note. Firstly, very importantly, that there is a world out there that is to be understood, and indeed a world in here that is to be understood. And for those of you who were at the free will session before this, you'll have been thinking a little bit then about neuroscience. And so there's a world in here to be understood and a world out there that we can understand, and we can understand its patterns, we can understand its structures, we can understand its mechanisms in precise detail. This is very important. Secondly, that our minds are wonderfully and unexpectedly able to do this. To my mind, there is no particular reason why it should have been the case that we could understand molecules like this, but we can. And the understanding we get is real, because another thing that makes this so important is because we can design drugs based on these kinds of insights, which you can feed to people and stop them dying. And that's a very, very important way of building on the kind of insights that this molecule exemplifies. Another thing I want to note is that it reminds us that our understanding is contingent. It depends on our efforts, it depends on what the world gives us, it depends on the efforts of others, it depends on our students and postdocs, those who work with us. So it's not just there for us on a plate. We have to work with it, and it is contingent. We are part of the world, and so we are contingent on it and have to engage with it on its terms and are frail within it in understanding how it is that it works. And of course, it reveals that my understanding can be tested and refined in a scientific way, because these insights can reveal the basis for experimentation, which I can then pursue to demonstrate whether particular hypotheses are correct. But fundamentally, and this is the thing I want to leave you with, fundamentally, because it is my engagement and delight in these kinds of structures that fuels my capacity to understand them, that really drives me forward and actually draws me in to ask first, what the hell? Or in another word, as Dan said, what the hell, first of all, but then you're drawn in and you think, now I can understand it. But I'm drawn in because I find it delightful, because it gives me joy looking at this molecule. And for me, this gives me something fundamental about science, which is that objectivity is engaged through subjectivity. Our subjective engagement, of course then using rules to test and refine our ideas, our subjective engagement is fundamental to how we then gain objective knowledge about the world around us. And for me, that is the key message I want to leave you with, and the thing that this structure and that my exercise as a scientist tells me about science as an exercise pursued by us all. Thank you.
Another picture of the universe. I am an astrophysicist. I grew up on a farm in a rural area of the United States where I was able to explore nature and see the stars in the night sky. I'm thankful I was able to go on to study physics at the university and then astronomy for a PhD. I was encouraged by my family and people in my school, my teachers, and in my church to go on and study science. I learned that stars are still forming. Regions like this one that you see in this image of a nebula in our own Milky Way galaxy that are very active, with the gas clouds between stars producing clumps of dense gas that collapse under their own gravitational pull, eventually creating new stars and clusters of stars like this one. Then the new massive stars send out powerful light and winds into the surrounding leftover gas cloud, creating the beautiful colors that you see here, and carving out pillar-like structures that point back toward the stars. It's in these dense pillars of gas and dust that lower mass stars, like our own sun, continue to form. Stars are still forming in many nebulae in our galaxy, and now we know stars form with dusty planet-forming disks around them. We use different kinds of telescopes as tools to study the universe. So here you see some examples. There's a space telescope at the top, the Hubble Space Telescope. The Keck telescopes at the bottom left are in Hawaii, and the ALMA array of radio telescopes at the lower right are in South America. These are just examples of different kinds of observatories that professional astronomers use. Different telescopes see different kinds of light or observe in different ways the universe from the ground or from space. So we need them all, like different instruments in an orchestra, all contributing uniquely to the full piece of music. So with telescopes like these, we get beautiful views of deep space that we could not see with our eyes alone. And we now know that stars that are forming in the gaseous clouds and nebulae, like I just showed you, and a large amount of unseen dark matter fill the volume of galaxies. This is a galaxy that you see in front of you. These beautiful structures can contain hundreds of billions of stars, as well as the nebulae and the dark matter that we cannot see. And if you look closely in this beautiful image of galaxy NGC 1309, you'll see other galaxies in the background of this beautiful picture from the Hubble Space Telescope. So now our sensitive telescopes are revealing that the universe is filled with galaxies. This image is from the new Rubin telescope, which has a very wide field of view, and it reveals countless galaxies. Each smudge of light here is a galaxy filled with hundreds of billions of stars and likely planets too. We can see some galaxies that are interacting with each other. We see beautiful spiral galaxies where stars are still forming in the nebulae that fill the spiral arms. It's images like this that give me the greatest sense of awe and wonder. I wish I could travel instantly to any of these beautiful galaxies and look around. Yet we are seeing these galaxies as they were when the light left them to travel to our telescopes, sometimes millions or billions of years ago. Astronomy is like a time machine. And these galaxies are not all at the same distance from us, which means that some are appearing as they were millions of years ago, and some are appearing as they did billions of years ago, closer to the beginning of the universe. We can compare the older, more distant ones with the ones closer to our own Milky Way galaxy in space and time, and get a sense of how galaxies have changed over the 13.8 billion year history of the universe. And we find that indeed galaxies have changed over cosmic time. They have merged with other galaxies and grown, and stars within them have come and gone, as you heard from Dan, creating heavier elements to enrich the next generation of stars and enabling planets to form around them, like in our own solar system. We needed previous generations of stars to come and go so that our own solar system would have the heavier elements that enable planets and life to form and thrive. So I'm amazed at how the universe has progressed over billions of years into a beautiful ensemble of galaxies that can support life, including living beings on at least one planet that can contemplate beauty and our own existence. I am amazed at being able to see this. It is fitting that this image is called cosmic abundance. And to me, it reminds me of Psalm 19 in the Bible, which says, "The heavens declare the glory of God, and the skies proclaim the work of his hands." And yet they use no words, but their message is heard throughout the earth. This is what amazes me. Thank you.
Hello. Hello, everybody. Brandon allowed me to formulate my own questions, which is about meaning. Okay. And I would like to start by saying that as Jennifer, I come from a very humble family. And I was completely lost. My father was study. And I didn't know what to do. So I talked to my teacher of Latin. And she said, José Ignacio, I mean, what are your options? I said, this. And she said, which is the most profound subject, the deepest? I said, physics. I said, you study physics. And I study physics, okay. And I will owe my teacher the best advice in my life, which is that I enter in the field where I have passion, I have vocation, I die for science, for discovery, for knowledge. And you know, many years after, here you have, I'm building quantum computers. And I've chosen this picture, which, by the way, it's very difficult to compete against the astrophysicists because they have these amazing pictures. But this is not bad. I wonder if people can guess what you see on the image. Yeah. So it's not trivial. So humans have reached the level that we control matter at the ultimate elementary level. We can trap a single electron, a single atom, a single photon. We can dominate matter. So science has reached the level of using as the basic elements to manipulate our surroundings, the fundamental elements of matter. So what you're seeing in this picture is a series of ions, of atoms, which are fully controlled by humans. We make them to be on a trap. And you see one by one. And we illuminate them, and we change the internal level, quantum level they have. So this has opened for us a fantastic new idea. Humans can use the fundamental elements of matter to codify information, to manipulate information, to transmit information. So we will have a new way of computing, a new way of communicating, a new way of sensing. So you see, we are simultaneously getting at the age of artificial intelligence and the control of quantum level of matter, which is amazing. Amazing. It's a disruption for us. Okay. Now I go back to the basic idea of meaning. And I go with a personal story. Brandon, again, allow me to use personal stories. It may sound very far-fetched, but let me go through it. So, you know, with age, you learn and you study and you think you understand better and better and better. So a few years ago, I decided to change the syllabus of my teaching. And I started, and I proposed my 20 students, I said, look, this year is different. We will go from 0 to the maximum humans can know. And we started day by day, 8:30 in the morning, to learn how to compute the basic processes of science with no concession, not one idea that was left out. And we took a full semester. And look, I was happy, okay, I did this thing. So the story is not that I did that. The story is that 2 months later, I got a letter from one of the guys in the course. He said, Professor, I have to tell you the following. You know, at the time you were teaching, and I was there every morning at 8:30, my father had a terrible disease. It was lung, and he died. And all my family was desperate. Okay. And I had no meaning in life. And suddenly, you were teaching 8:30 in the morning, from 0, truth and beauty. Truth and beauty. And that changed, that made me survive. And now that my father died, I really have to write to you to say that your teaching of science to me changed my life, okay, and make all my family much better. So I think there is a story that illustrates that the meaning, that science brings meaning to the life of people. And I'm using the experience of another person in this particular case. But I think it's very impressive how deeply science can touch the soul of a person. I'm one of them. My student was another one. Back to you.
Thank you. Thank you all. Those were wonderful examples. There is, I suppose, a contrary position to what José Ignacio just laid out, which was put out by the prominent physicist Steven Weinberg, who said that the more the universe seems comprehensible, the more it also seems pointless. And I'm curious, I mean, of course, there are ways in which science can be experienced as meaningful, but there is a critique that some people think the more we've learned about the universe, the more we've learned about evolution, the more life in the universe and everything seems pointless. So I wonder how you might respond to that, and maybe perhaps, José Ignacio, if you don't mind, can we have you go again?
Okay, Brandon, you're the boss, you're the chairman. So. If you have ever read Steven Weinberg, the 3 first minutes of the universe is a fundamental book. Let me say something. The more you learn, the deeper you go into science. It's a journey. It's a journey for me. I think I understand science in such a different way from when I was younger. I think I've learned. But I would like to bring one idea here. I think that science, we should be very clear, is the narrative that humans are making about the world. Okay? It's the way we use our brains to think what is happening out there. So, to me, it's a clear distinction between what may be reality, okay, and what is the way humans try to understand reality. Science is written in equations that if another civilization appears in the cosmos, may be different, may be completely different, okay? there are studies that, what about if science were done by, had not appeared, mathematics and so on in the 17th century in England, but in another civilization, would science be different or not? Or whether it was done by more women than men, would it be different? Okay? So is it a unique science that we are discovering, or is it a multiple one? So if it is a narrative, there are possibly many ways to understand the cosmos. So the more I've learned in my life, the more I understand that the way we understand nature may be temporary, that we may get to a far deeper way of understanding nature. I'm convinced about that. And I don't know whether purpose or meaning is something which exists outside of the human brain. So I'm not sure about that. So the question of Weinberg, I would love to discuss with him. By the way, I did him many years ago, and I would like to discuss with him in these terms, okay? Whether it's something which is absolute or not absolute, the idea of purpose.
Okay. Jennifer, how would you respond to Weinberg's provocation?
I think, like most quotes that are kind of taken out of context, we would need to know the bigger context of his comment. But part of me thinks he makes a good point, because as much as we love seeing the grandeur of the universe, as I showed in these beautiful images, as we project the possible long-term future of the universe, it can seem kind of bleak. We think the universe will continue to expand and maybe cool off and freeze out, and stars will die out, and then you could conclude that maybe everything will be lost and that the universe is pointless. So I can sympathize at some level with this comment. But it is not my own conclusion, because I think you can only conclude that if you somehow believe that humans must be the ultimate purpose of the universe. And we have already found, of course, that planet Earth is not in the center of the solar system, nor are we in the center of the galaxy or the universe. And so our significance is not because of where we are or when we are, but that we are at all. And the age-old question of why is there something at all and not nothing is a very important reflection. And the fact that the universe is endowed with these fundamental properties that have enabled it to develop into a place where stars can form and planets can form and life can evolve, even life that can think about itself and have the conversations that we're having today, to me, shows us that it is not pointless. There is a purpose for all of this. We may not know all of that purpose right now, but there, to me, is obviously something very important about the universe and about the fact that we exist to reflect upon it. And, this is where things beyond science come into play, things like faith and philosophy. And I know we'll get into that conversation later, but that's my response.
So I'd like to answer this point.
Vorrei rispondere in particolare.
So what I'd like to do is I'd like to, first of all, make some quite general comments and then focus in on my own science, where I'm coming from myself. So the general comment to make is that I think scientists need to act as if there is meaning in the universe and as if it is not meaningless. And I think that's because in doing our science, we need to believe there's a logic and a coherence and actually in some ways a purpose, a local purpose at least, for what we're studying that we can tease out. And actually this mention of logic also, we need to couple with this morality too. So there's a kind of morality that scientists need to follow. They need to believe in the truth. And I think believing in the truth is a wager on the side of meaningfulness. And although you can be a great scientist and have a relatively poor personal sense of morality or adherence to a moral code, I personally think that any scientist is a better scientist the more they follow a particular logical commitment to truth, to doing the right thing, to believing that some things are false and some things aren't false. And of course this is the basis for experimentation and falsification and so on. So I actually think it's quite important that we believe in meaning in that big sense. And part of that moral code is actually the scientists to have a sense of humility as well before the reality that they're studying, to allow the reality to speak to them and not, to be so busy trying to tell reality what they think it should be like that they can't hear it. They can't hear it speaking to them. So that's the big picture. I think we have to act as if there were meaningfulness to the world in order to be able to understand it, and we find that understanding is real because it helps us to change the way the world operates. On the smaller scale, as it were, focusing on my own kind of work, I just comment that the fact that people like me find such meaningfulness and beauty, and through the beauty something new and truthful to understand in what we study, tells us that just that local practice of believing that there's a value and a coherence to what we're looking at, that helps us to understand it for itself. And as I already said, it makes a real difference, because those insights are not just subjective, because they enable us then to make objective changes to the world, which include making drugs which stop people being sick or stop people dying, and there's nothing subjective about that. So that's where I think there's a real value for the seeing of meaning at the local scale, but I think it's part of a bigger picture, which is that scientists in general have to act as if there were meaning in the world in order to be able to understand it.
Occorre quindi credere nella verità e nel desiderio di scoprire il senso.
Steven Weinberg was a very clever guy, but this statement of his is a little strange in my view, because saying that the universe to him seemed to have a point and then become more and more pointless presupposes that he thought it had a purpose and then he realized that it doesn't. But I personally have never seen any evidence that the universe has a purpose, because that implies that there is some being, some presence, some power, that is their this is all their project. They created everything and they're supervising it now. And even as most people in this room believe, is actually watching us and our actions and rewarding us or punishing us according to our behavior. So being personally an atheist, this has never spoken to me. Or stated more simply, to me, the universe has always seemed pointless, but that's not a bad thing. That's okay. That's because the universe is just what it is. And I've been very fortunate to be able to have a job to simply try to figure as much of it as possible.
I think it is striking that the variety of ways in which this experience of profound beauty and awe and delight and wonder that each of you can find in the scientific process could lead you in different directions when it comes to this question of meaning, right? And whether the encounter with beauty and wonder is a doorway to something, pointing to something beyond science as then giving the universe value, or that really it's what it's showing is that really it's sort of giving maybe more evidence for the position that there really is nothing out there, and where meaning is to be found is perhaps simply in one's own response, in one's own engagement with this experience of wonder. I'm curious, though, then, if each of you could perhaps speak to how is it possible then to have a scientific enterprise that is, I suppose, sustained by such different positions, right? If you, in your engagement with science, can engage with colleagues who have such different positions on the meaning of things, how does that, I suppose, shape the way in which science is done together? How does that shape perhaps the sense of community? Does the risk, I suppose, is that it could trivialize the experience of wonder and awe and beauty to something purely subjective, that ultimately what then matters might be just the publication of papers or whatever objective standard one might come up with. And I'm curious to know if each of you could comment on what is the value then of this subjective experience, this sense of profound wonder. Why do we need it? Does science need it? Does it need to be sustained? Does it matter for human beings? Is it central to the meaningfulness of science as an enterprise, as a human enterprise? I don't know. Well, mix up the order. Maybe Jennifer, if you want to get started.
I think one of the things that I value most about being a scientist is being able to work with colleagues who have a wide variety of perspectives, of faiths, of cultural backgrounds, and what unites us is curiosity. And science is a wonderful structure for helping us to answer questions about the natural world, about the physical world. It gives us a unified structure, a unified approach, a unified way to ask and answer questions that can be answered through measurements or through mathematics. And so science is a gift in that sense, but science doesn't answer the meta questions, the bigger questions of why is there anything at all, the sort of philosophical questions, or the ultimate religious questions. Does God exist? How do we have a relationship with God? What does God want with us? So those kinds of things are a little bit outside of the strictures of the processes of science. And so I find it marvelous that science unites us because we have a unified sense of curiosity, and yet we can still have a diversity of interpretation in that bigger sense of how does this inform our sense of purpose, or as you mentioned, is there a purpose, is there meaning, these kinds of things. I don't know if that addresses the question, but that's my initial thoughts there.
Thank you. Rob, as an Anglican priest, I'm curious to know what the ways in which your scientific quest has shaped your sense of meaning in your own vocation.
So, yeah, this is my own vocation. So, in science, this appreciation of beauty in science and the valuing of things that we study, one thing it does is it it helps to bring scientists together around things that they agree are worth studying, and then when they see the results that they really, that they really delight in. Thank you. That they really delight in. Together, that it's a source of unity. And so, for me, actually, the way in which I see beauty and value and meaning in science is one of the really excellent things about this is it provides a source of greater unity than there might be. As Jennifer says, and it's the same for all of us, we will work with people from different faith backgrounds, no faith, and different specific faith backgrounds. But what we can agree on is the things that we delight in together, the small-scale things that we study and delight in, and that's one of the things that for me is a real value about the particular perspective I have on science. But I think I share it with everybody else really who is doing science with me, that we all delight in what we study. Now, Brandon broadened the question to ask about my personal vocation, and what I would say about this is that my personal vocation has been a long development for me to end up becoming a priest. It was very much about trying to understand how I could serve others better, and I suppose one way in which my scientific exercise has played a role in that is as a teacher. That's been a form of service, and I found the need to broaden that service into the normal pastoral and liturgical roles that a priest would have in a community. I also had, as part of my academic role as a scientist, mentoring roles towards students, both who were with me and in my kind of area, but also more generally, and that also has been something that I've built on in my vocation, my realization of my vocation as a priest. There's one thing I was actually thinking about this as Jennifer was speaking. There's one thing I'd also say, which is that this thing I was saying about beauty being something that scientists can agree on, it brings us together. We study something, we delight in it, we appreciate it together. Even though we might disagree about quite what it means, we can appreciate that this is a good insight. It reminds us of something that really unites us. And also in my vocation, I would say that it's lovely to note the things that unite people of faith, people of different Christian traditions, but also people of different faiths, and indeed, actually, people of no faith and those who have faith who believe in truth. And I think that actually, this beauty thing in science is a kind of microcosm. It's a small example of something which is true about scientists in general, and indeed faith traditions in general, and which has been a real important aspect of my vocation. But the things, if we're talking about faith, one of the things we can do is pray together. If we're Christians, we can say the Lord's Prayer. We can all say the Lord's Prayer, whatever tradition we come from. And the analogy in science is we can look at the particular thing we're studying and agree it's worth studying and agree that there's delight in what we find there. And all scientists, whether they see meaning in the universe or not, whether they are atheists or come from any particular faith tradition, they believe in truth. They believe in truth. So it reminds us of the things that unify, not the things that separate. And that's one of the lovely things about science, is it is actually done by practical scientists on the ground and staring at the heavens.
Un filo rouge tra I due aspetti.
So Dan, I'm curious if you could comment on, I suppose, how you make sense of your religious colleagues, in the sense that if science can really, can science really provide us with enough of a sense of meaning that we don't really need anything beyond it? And if it could do that for scientists, then why might some scientists need something more like faith, right? Does that make sense? I'm just curious to know how you would think through that.
Yes, so I completely agree with what Jennifer and Robert said. That as scientists, we do have a common language and a quest for the truth, and the idea that there really is such a thing as truth, which is not very popular nowadays. There's all sorts of alternative truths and so on. We don't believe in that. We believe in one truth that's out there, and that we can reach it many times. I have many colleagues who are non-believers like me, but many who are also deeply religious, and I have great respect for all of them. I don't presume to know something better than them. Maybe they are right and I am wrong. The Professor Marco Bersanelli, who invited all of us here, he's a world-famous scientist who, with his teams, has discovered profound truths about the universe. But he's also a deeply religious and devout man, and I respect that completely. And obviously, it hasn't interfered with his pursuit of science very successfully. I can't claim that I understand my religious colleagues, how they live with this simultaneously in these two worlds, where in one, the scientific one, you have to always be very skeptical, very doubtful, not believe anyone, not believe anything that you don't see with your own two eyes, and at the same time believe religious truths that were handed down to you and believe them equally on the same level. I don't understand this, but I certainly respect it.
Ignacio, I mean, you could either feel free to reinvent the question, or I'm very curious about a point you had raised when we were chatting. You had mentioned an interesting encounter you had with John Polkinghorne, the famous scientist. I wonder if that conversation might be relevant to what we're discussing at the moment.
Yeah,
if you could relate that.
That was a heavy conversation, yeah. Can I say one thing about wonder? The first thing is that Marco wrote a book on Only Wonder Knows. That's how I met him. And in particular, the ideas of simplicity in science have driven my mind. The unification of a unique law for the universe. That's the ultimate wonder in my mind. Okay, that there is a simple description. But again, a personal story, which is I met John Polkinghorne, Beyond Science, and it was very impressive for me, very impressive, because I was saying the same words that Daniel was saying to him, and I was confronting him, and he said these words to me, and he said, "You are a coward. You do not dare to go into the deep questions." And I was taken aback because instead of defending, he gave as a given that he had gone far beyond me, okay? And that I'm coming behind, no? And I think he was right. Okay, so actually it made me go much deeper in my way of thinking, more respectful to all opinions, and humble. As I feel of not having a better answer for anything, but he changed me, definitely.
Thank you. I wonder if each of you could leave us with a bit of advice. And the reason I ask this is, well, for one, my own experience of science when I was in high school was perhaps very different from yours, because it was not a doorway to wonder and beauty. It was something you did in order to get a good grade, to get a good job. You memorize it. So maybe there are some people in the audience who might have had a similar experience of science. I had never seen it as a worthwhile path to meaningfulness, or sorry, this is my high school experience, right? It was not really until I met the scientists that I studied and heard their stories of the profound beauty and the wonder that they experienced, that science really opened up for me a pathway to the mystery, a pathway to the infinite, a pathway to things that brought me delight and joy and wonder through the eyes of others. And it's led me to I suppose the hunch that science can be a spiritual resource for all of us. And so might each of you be able to offer a way in which the practice of science could be valuable as either a spiritual or existential resource, as something that can help us along the journey towards the infinite, towards the ultimate questions, towards what ultimately matters, even if we're not, professional scientists. And maybe Dan will start with you and
Well, for me, the most important trait of a scientist, which I use daily, and one which was actually, I think Galileo Galilei was the first one who gave us this, is skepticism and doubt. Don't believe anyone, don't believe anything, and always question. And I think this is good advice for anyone, whether a scientist or a layperson. Including when examining questions of faith and purpose and so on that we've been talking about this evening. I think what makes us human is our curiosity, and curiosity in its essence is a sense of questioning, finding out new things and finding out if they're true. So that would be my one-word advice is skepticism.
I suppose it would be a kind of skepticism that is. I don't want to put words in your mouth, but is it skepticism for its own sake, or is it a kind of, one might say, an open-mindedness in order to try to arrive at something more solid, right? To verify, to experiment, but in order to really try to go beyond simply what's given.
Absolutely, it's a tool. It's a very useful tool that our brains have developed, and apparently it was useful because otherwise evolution wouldn't have given it to us. Right?
Thank you. Rob, how about you?
So I'd like to follow on from what Dan was saying. I think the critical thing here is open-mindedness. And one piece of advice I'd give is that if you're presented with a new scientific insight, and sometimes these things are very hard to get our heads around. I'm a biologist, so I can understand biology easily, but I don't understand physics, and I certainly don't understand maths well at all. When you're presented with something, and it seems confusing, then see that as actually a kind of an experience of open-mindedness, because you don't know what you're looking at and you need to try and work it out. And then think to yourself, actually, the scientist was in the same position as I am. So actually, in a way, you're experiencing, again, what they experienced when they first tried to study the thing that they're now presenting to you as a neat model. They also were confused. And what you're experiencing is an aspect of the open-mindedness that scientists need to follow. And you're also echoing, in a way, something like the experience of what it was for the person who discovered what they did that you're being shown. But to finish, what I'd say to all of you, because you're all scientists, you're all people who look at the world, you notice things in it, you are curious about them, you are moved to spend time looking at them because they delight you, and so on. All of that is a scientific exercise. All of you, in trying to understand the world, are being scientific. You're trying to gain knowledge about the world. What I just suggest to you is that as you're doing that, reflect on the ways in which it's your interest in, your delight in, the beauty you might see in an everyday kind of way in the world that's drawn you in and made you want to look at something and try to understand it or just spend time with it. Consider that and think how it might be a reminder, or actually for you, an existential experience, a personal experience of the old truth that love and knowledge are reciprocally related. We cannot love what we do not know, and we cannot know what we do not love. And love and knowledge come together, and through love and knowledge, in that age-old combination, that's how science works, and that's how all of us engage with the world, through knowledge, love, and through knowledge.
Jesus was once asked, "What's the greatest commandment?" And he said, there are two: to love the Lord your God with all your heart, mind, soul, and strength, and to love your neighbor as yourself. So I think we can apply how we think about science to these two principles. One is to have a sense of humility. I think this is where curiosity comes in. As we learn more and more about the natural world through science, all of us, whether we are scientists or not, whether we are people of faith or not, can take this sense of curiosity seriously to study the natural world with science with integrity and to appreciate what we're learning. And for people of faith, that includes enriching our sense of worship when we understand more about the wonders of creation in the natural world that we've learned through science. But the second principle of loving our neighbor means, what do we do with this knowledge as we're learning more and more about the universe, the natural world, in biology, in physics, astronomy, chemistry? What are we using this knowledge for? How can we use it to better serve others, to make the world a better place, to be a blessing to others? And I think myself, as a scientist, most of our days are not filled with being able to just contemplate beauty and wonder. Most of our time is spent, like all of us, answering emails, dealing with budgets, working with our colleagues. How do we do this in a way that really blesses people around us? So I think one thing we can learn is the way we do science and what we do with that knowledge should be done in a way that blesses the world and honors God. And that is the best way I think we can use scientific knowledge and the practice of science in a way that brings joy and help to the world.
Quindi aiuto e gioia al mondo.
Okay, so my final words, I would like to use them to praise creativity in science. I do think this is the ultimate human quality, okay? The fact that we can create understanding. It's highly non-trivial. I think it's the ultimate level of intelligence, not creativity. So this is how we operate in my teams. It is compulsory to be creative. And that implies many things: questioning, being honest, being open-minded. All these things are necessary to being creative. And I do believe that, I will repeat it for the last time, this is the ultimate level of intelligence, creativity. So that's what I hope to keep alive, creative. Okay, that's what I hope. Thank you.
Well, thank you, each of you. I've learned so much, and I'm sure all of us have, about just how the beauty of understanding that science affords could really help us live more fully, fully and deeply meaningful life. Tomorrow at 12:15 at the Homo Faber exhibition curated by Marco Bersinelli, which I invite everybody to see if you haven't already, there will be a question and answer with some of us, so we do invite you to join us if you can. Once again, I want to thank the John Templeton Foundation for sponsoring this session, Marco and the organizers of the meeting for inviting us. You can learn more about our project at meaningandmysteryinscience.com. And once again, please join me in thanking our speakers.
Grazie ancora per essere stati con noi.
Yeah, thank you. That was amazing. I enjoyed that.
Questo è un luogo che genera dialogo,
Qualcuno che si impegna, che si batte.
che approfondisce la conoscenza e sostiene la fiducia. È un crocevia dove si incontra chi desidera il vero, il bello, il giusto e il bene. È una testimonianza di speranza nel cuore ferito del presente. E tutto questo esiste anche grazie a te.
Alla fine, cioè, non so tutta quello che sentiva, secondo me svegliamo. Cioè il tizio qua di fianco lo sentiva. Sì, era gli altri. Quando ha parlato qua.
Bravi ragazzi. Ragazzi sono molto bravi.
Ci sta.
Povero me.